All right, good morning. Welcome to Tuesday. Cat gone, but not forgotten. There's a whole slew of those. Hopefully pets don't mind when you do that to them, but I don't know. All right, so, any questions before we continue with Swing and Window Builder and Eclipse? Oh, cats do not like shirts. I had a 270 student who wanted to do his labs in Minecraft, and I probably should have let him do it. Yeah, let's talk about printwriters. You can assume the database file has at least one question and two answers. The smallest file I'll start with is that kind of default 20q.txt. So you don't have to worry about the empty file edge case. All right, so let's play with printwriters a bit. Method that plays the game and asks the input, does it have to be recursive? No, it's probably best done as just a while loop. While the current node is a question, ask the question, get a yes, no, change to the yes or no child, go back to the top of the loop. And then when the current node is an answer, you kick out of the loop and your game is done. Tell the person your guess, and if you're correct, good. If not, then do the dialogue to patch up the tree, write it out to the file, and then you're done. So you can do Y or N. Yeah, so the most convenient is just to do, you know, Y for yes and N for no. If you also allow those or yes and so on and so forth, that's fine. I'm going to hope that you just do Y or N, but I don't think I required that in the write-up. I'll have to go back and see what I actually said, but if it's all the same to you, yeah, I would definitely accept a Y or an N as a yes or a no. Let's see. So yeah, not required to do that specifically. Loops are like the lesser form of recursion. Yeah, sort of. All right, let's spin up some printwriters. Loops are the ugly cousin of recursion. Yeah. That might, I don't know, different but similar. All right, so printwriters we have to import. They come from java.io. And I don't remember the camel casing on that. So let's just check that import statement. Okay, so it's printwriter with camel case. All right, so let's make a printwriter. So printwriters you can construct with just a file name. Scanners you need to do the new file business, but printwriters you should be able to construct with just a file name, and it will force us into a try-catch block. So we'll assume that we can open our file, and we'll just error out if we can't. And if I just close my file right away without doing anything else, that should create an empty file. Alright, so there's our output file.dat, which is empty. It was just created. But if you want to print into here, it's like system.out.println, but pw.println in this case. Down here we could say but you got to spell print line right. So now we got a output file.dat, which is 15 lines, and it's got that inside it. And if you look at it in binary or in hex, right, it's our, this is a test followed by the ASCII code for a new line, and that's it. So print line says add a new line \n ASCII character 10 to the end, and that's the end of the line. So we're using a print writer in PA3 to print out our decision tree into the database file. So make a recursive node left right method. Maybe pass it a print writer. And if this is done inside the node class, you've got a question answer flag, you've got the text, you've got a yes and a no child. So this is, you know, the nice recursive traversal code from 222. So if the current node is a question, print out a q colon, print out the text, and then do yes dot node left right pw, and then do no dot node left right pw. In other words, call this method on those yes and no children. Otherwise, if this node is an answer, just print out a colon followed by the text and don't do any recursion, right? But the recursive calls would just look like this. Right, so that will do the entire left subtree. And so from the, you know, recursive goggles point of view, or the non-recursive goggles point of view, right, what does your NLR method do? If it's a question, it prints out a q, prints out the text, and then prints out the yes tree, and then prints out the no tree, right? How do we do the yes tree? Well, we're calling the same method, but don't worry about that, right? We're just using this method inside the node class to print out that node's subtree to that print writer, that file. For the print line going to the file, I assume there's a way to append like we did in C one time, but here we just want to overwrite the file. So if you construct a new print writer, that will overwrite the file. So right, so here's my file right now. It's a bunch of hello worlds. And if I run this, then it obliterates the file and replaces it with whatever gets written out. So constructing the print writer zeroes it out. How do you open two terminals like that? So I'm using a program called Console, but most programs have tabs. And there's normally a menu bar that I have suppressed by default, but there's either under Files or Tabs you can open up a new tab. So for me, I can just hit Control T to open up a new tab, and I can do whatever I want in here. And you can click back and forth between these, but I've also got keyboard shortcuts for doing that. And then if I want a totally separate window, I can grab this tab just like in Chrome or whatever. I can just drag this outside, and now I've got two windows. The only advantage of doing that instead of just doing Control Alt T to open a new window is that when you make a new tab, you're in the same directory. So I already traveled down into a subdirectory here. So by making a new tab, I'm still in that directory. And then you can Control Scroll Wheel to make it visible, and Alt Right to resize it and move it without having to precisely hit the corner and stuff like that. So customize your environment, right? When you have downtime or you need downtime, play around with your tools and figure out what works well for you. It will spoil you, but it will make you more efficient. But I'm totally spoiled now. When I go back to in-person and I have to use like other people's machines, it's gonna be horrifying. I'm gonna be like, what do I do? All right, so that's print writers. Do you want any text files in our Git repos? I don't mind if you have them in there. I probably won't do anything with them, but they won't bother me if they're in there. As long as the .java files are in there, and if they're not all sitting in the top level directory, if you played with packages or put things in a subdirectory, give me a make file so I can say make. But yeah, you can put whatever you want in there. But don't put in, like two Java files that each have a main method, because if I, Java C star, it's going to get wonky. Thou shalt have no free time. Did he actually say that? That's a good quote. Ah, well, yeah. It is implied, and it is probably true, but free is an interesting word, right? We got time to make, things like this. All right, let's continue with Eclipse, and let's dig a little further. Any other PA3 questions? All right, so let's go a little deeper with this stuff. Yesterday was Crash-O-Rama for Eclipse. We'll see how it does today. I'm going to delete all of these, man. I'm going to delete a lot of these. So when you want to delete something, you can remove it from Eclipse, or you can actually remove it from your drive and actually get rid of all the stuff and clean it up. So that's what that little checkbox will do. Wipe out all of these, man. We're going to start with a clean slate. All right. So you're going to say File, New, Java Project, and we'll call this Tuesday morning. And let's say File, New, Other, and we'll do Window Builder, and Swing Designer, and JFrame. And we're just going to call this Main. And let's go over to our Design tab. And so here's, our classic J-frame template. It's going to do the absolute layout. And let's play with a button. So we already started dabbling with these. Let's dig a little deeper. So there's a button. You place it. You have the text on the button highlighted. So usually you don't want a button called new button. So you can give it a label as soon as you start. You can come down here and change the text attribute if you make a typo or change your mind. So there's a button. All right. And all the things that we played with yesterday with labels, you can do with this button also. So you can change the border, you can change the color. If you want, you can set an icon and put an image on it, which is kind of cool. And you can change the sizes of it from right here. You can make the really awkward looking button that's like really hard to click, and so on. You could change the font to Wingdings. That would be cool. But it's going to have to be red Wingdings, right? So we can go with Dingbats. Didn't save that. Alright, and so again, sometimes for some reason this week when it comes back, it doesn't seem to want to open or display this file that we were editing. So I'm just going to close out that tab. I'm going to click through to the source in the default package, and then I'm going to double click to open that up again. Save after every keystroke, yeah. So, oh man, I thought I was saving it more often than that. All of that, and we lost. Okay, well, I'm going to put the absolute layout again. Put the J button. We'll label it up. I'm going to save it. Now I kind of want to do like webdings and see if that was the problem. So we'll go with Dingbats. Yeah, that's not a font that has characters that we can see. Font awesome. There we go. That's pretty awesome. All right. So you can do all this stuff. Let's play around with some of the methods. So let me right click on here and let's go down to event handlers. So one handler is focus. So focus means that that when you type, that's going to be the thing that receives your keystrokes. And you can have multiple things, multiple widgets on a window, and you can move between them. Usually you hit a tab key and it'll move from one to the next in some predefined order. So we can say when this widget has focus or when it loses focus. Let's go for key, and let's do key pressed. And so it creates some code for us and drops us down here. So let's just start off with a message. And just say a key was pressed. So if I come in here, clicking the button doesn't do anything, but if I hit a key, it tells me a key was pressed. And when I first started to run this, let me clear out my console here. When I first run this, I'm over here. Okay, so there's no key pressed. And even though I haven't clicked on that button, right, when I hit a key, it's telling me a key has been pressed because this button has focus. Now, if we put another button in here, and we run this, I saved it. You can mess with different versions of this and maybe get it to crash less. And like I say, this has been a rough week for Eclipse so far. It usually doesn't. I mean, it crashes sometimes enough that I mentioned it the other day, but it's usually not this frequent. On the other hand, I'm doing kind of strange things. And I guess we could dig into those log files when it crashes and see what's really going on. So if I click on this button and I start hitting keystrokes, right, it's not telling me key press because this thing doesn't have focus. If I click on that other button or if I hit a tab, you can see there's a very faint outline right here around new button. If I hit a tab, that changes to my dingbats button, right? So now that button on the upper left has focus. And you can also do that by just clicking. And once that has focus, then if I press a key, it will respond accordingly. All right, so let's go in here and let's look at what happens when this key gets pressed. Well, the key pressed. So let's do a bigger picture view here, right? We created a button called Click Me. Okay, so that was a J button. So we construct a J button with an argument, which is a string, which will be the default label. And then in that object, that button, we said, let's add an action listener. Now, add action listener says, basically, I'm going to give you a method that I want you to register with Swing, or with the operating system, if you like. I'm going to give you a method to register so that when this button gets clicked, you call this method. Or when a key is pressed, you call this method. Or when this button is resized, you call this method. So this is like setting up an interrupt response. So we're saying create an action listener. So when an action happens on this button, you're going to call this code down here. So this would be handling a key click. Down here, we also said on that button, let's add a key listener. A key listener is a different type of event we're going to register. And we're going to say when a key is pressed, when it's released, when it's typed, and so on. Go ahead and call this key pressed method. So we create a key pressed method, and it's called with an argument, which is an object of type key event. So when a key is pressed, this code starts to execute, and it's called just like a regular function call, and it's given an argument of type key event. So let's look at a key event. So an event which indicates that a keystroke occurred in a component. We can read all the fine print, but we won't. But basically, key pressed, key typed, which is pressed and released and generated a valid Unicode character, and key released. And so inside a key event, we have a number of fields, right? Key first, key last, key 0, 1 through 9, key A through Z, alternate, left brace, right, caps lock. All these different things are, symbolic codes to represent these types of keys, function keys, and so on and so forth. And if we go past all of those, we get to the methods. And so we can say get key character, get key code. So a character will return the actual character. The key code will return a number corresponding to the key that was pressed or released. Get key text will return a string, like home and F1 and so on and so forth. So let's try this. Let's print out key pressed. And let's use the get key code method on E. So I'm going to run this, and I'm going to type the letter A, and it tells me key pressed 65. Well, guess what? That's the ASCII code for an A. If I hit a space, it tells me 32. That's the ASCII code for a space. If I hit the Enter key, it gives me a 10. Now, Enter is a carriage return. That's really a ASCII code 13, but on Linux, Enter keys generate a new line, which is ASCII code 10. If you do this on Windows, you might get a 13. I actually don't know. And, 49 through 57 for keys 1 through 9, and so on. Now, if I hit the Shift key, it says key pressed 16. So the Shift button on my keyboard is not generating an ASCII character, but it does generate a key code right in the hardware of the keyboard, and the key adapter, right, is picking that up as a code 16. The right shift is also doing a 16, so this level won't differentiate between left and right shift, even though they generate different codes in the hardware level. Here's my control button, that's a 17. Here's my alt button, that's an 18. Here's my Windows button, that's a 524. So if I press Shift A, I generated a 16 followed by a 65. There's escape is 27, that's its ASCII code. Here's F10, that's 121, and so on and so forth. Here's my arrow keys. Right? So you can use this somewhat to pick up more detailed information other than just the ASCII code that was pressed. So there I did an Alt F4 and it picked up the Alt, but then the F4 closed out my window. So let's play with the key character. So if I do an A, it tells me the character is an A. If I do a Shift A, it tells me the character is a Shift A. Right? Even though the key press was still a 65, it was preceded by a shift. Right? And these things like Shift and Alt and Windows keys don't map to ASCII characters, so I get my little, FF in a box as usual. And there's a new line, and so on and so forth. All right, let's play with this key text. Let's just print out the key text, which I spelled wrong. So get key text is a static method which takes a key code. So how do I call a static? I'm going to say key event, the name of the class, dot get key text, and then the argument I'm going to pass it is e dot get key code. Right? This is PA2 business, right? So E is a key event. E has a method called getKeyCode, which returns an integer key code. GetKeyText is a static method in key event, so this invokes that method and it passes to it the key code that was generated in response to a key press and passed to this key pressed method as part of its argument. And if we do all of that, great happiness abounds. 1, 2, 3, but if I press the Shift button, it tells me Shift. There's Control, Alternate. There's Enter. There's F1. There's my Windows key. Wow, it still calls it Windows. That's sad. Because on my keyboard, it's the Coolmaster key instead of the Windows key. All right, so great deal of control over just this one type of event. Yeah, the hacker man key. All right, so that's just key pressed. We can also do key released if you want to know when the person lets up the key, and so on and so forth. I think we played with mouse entered the other day. Let's play with some of these other events, but let's do it on this J panel so that we have more space to work with. So let's add an event. I should do some tags here. Let's do mouse events. Let's right click on the J panel. Let's add an event handler. Let's add a let's do a mouse motion. And let's say mouse moved. All right. So same setup as always, right? We've constructed our J panel. That's the thing we're going to place the widgets on. In that object, we're calling this add mouse motion listener method, which we're passing basically a class that contains a method called mouse moved. We'll take this apart tomorrow. But we can just drop in here and say let's just say mouse is moving. And so now if I bring this in here, anytime I move the mouse in this panel, I'm going to get a mouse is moving. Now if I move on the buttons, I don't get those events because the mouse motion is being handled by this button, right? If I had a mouse motion listener in this button object, then it would be invoked. But anywhere else on this panel, right, I'm generating an event every time the mouse moves. Now if I click the left button and hold that down and move, I don't get those events. This is a mouse dragged event. But if I don't have any buttons pressed and I'm just moving, I get an event every time that the mouse changes position, right? Up to the response time of the system. All right, well, the type of argument passed to this is a mouse event. And mouse events, right, are classes like everything. And there's some fields defined for buttons and states and so on and so forth. But we can say get button, return which, if any, mouse button has changed state. Get click count, the number of mouse clicks associated. So if we're using a scroll wheel, right, we might generate an event when the scroll wheel changes. And you can set up your scroll wheel to generate, 3 or 5 or 2 clicks. Get point, get the XY position of the event relative to the source component. So a point is another type of object, which basically holds an XY pair. And we deal with XY coordinates enough that sometimes it's nice to have a single object that contains both pieces of information. So that's typically a point. But we can also get, individual X and Y coordinates. We can get X and Y coordinates on the screen. So let's play with that for a moment. So let's just take our argument E and let's say get X. Right, so I'm going to say the mouse is at parentheses, X coordinate, comma, Y coordinate, close parentheses. And so if I bring this in here, it's telling me where my mouse is. So upper left corner is 0, 0. Except you can't quite get there. And then X increases to the right and Y increases going down. So this is a general thing about computer graphics. The y-axis is flipped from what we learn in math classes. X goes across, Y increases going down. Origin is in the upper left corner. That's pretty universal. Scratch does it the way that you would in geometry, but that's because they're targeting children who are learning Cartesian coordinates. But most graphic systems use this, which is kind of inherently backwards, but I think is a throwback to, you know, the idea that when you have a CRT, you're doing a raster scan. That's the way you do it, from left to right, most quickly and slowly moving from top to bottom. And so the early graphic systems, right, a coordinate of 0 meant, you know, the beginning position for your raster sweep and then increasing as you move down. I think that's tied into why we still do this. But it's backwards, and it takes some getting used to. But so Y is 0 near the top and increases to the bottom. Now if I get up into the title bar, right, I'm not picking up those events anymore, but as soon as I get into the panel, right, it will pick those up. And I can get my Y pretty close to 0, and I can get my X to 0. And if I make this bigger, right, I can come over here now. Now, if for some reason you want to know where the person's mouse pointer is on the entire screen, we can do get X on screen, get Y on screen. And now if I run this, it tells me I'm, you know, at 4,000 something. And if I bring this down further, my Y coordinates are around 700. If I bring this up to the top, my Y coordinates are around 0. If I go all the way over here, right, my coordinates are 5,700 and 963. Right, so that's your coordinates on your entire display. And I have an extended display, so my upper left is actually, you know, 3860. And I can drag this over to my other monitor and get down to the lower coordinates. And if I put it in the upper left of my primary monitor, I can get coordinates close to 0, 0. Right? Is that useful? Who knows? It'll be useful sometime. All right. Hopefully your brains are kind of exploding with possibilities at this point. For things you can do. Yeah, moving button. So how about mouse entered? So when we enter the J button, so what should we do? Should we just have the button scoot out of the way if you enter it? So J button, where do we set its position? Set bounds. Yeah, let's make the button move. So I mean, I don't need to put these things in separate integers, but I'm just going to do it because we're figuring this out on the fly, right? So let's just do x equals x plus 200, y equals y plus 100. And then let's roll these things over so that we don't go off screen. So how big is our J panel? Is that a thing? But it's not called a J panel. Content pane. So I'm just going to be goofy here. I'm going to take your x coordinate and your y coordinate and increase them, and then I'm going to roll this over at the width and height of the panel, so I'll just use a modulo operator. Take x modulo the width of that content pane, and I'll do the same for y. Wow, my keyboard is being weird. And then button click me. Let's set the bounds to, so I think this is x and y. I think this is position and dimensions. I'm not sure. Let's see what this does. So there's my button, and every time you go to click it, it's going to jump away somewhere. Oh, that's unexciting. Well, yeah, so you can do goofy things. There we go. We're actually solving a fairly classic problem in discrete math, actually. Because will this button ever converge to a point where it never changes position? Possibly. Anyway, so yeah, you can do all kinds of things, right? Call the button, don't click me. Yeah, exactly. It's a really good idea. There we go. It's strange that it seems to converge. Yeah, there's a Diophantine equation analysis that could happen there. What else? So keys, mouse motion, mouse wheel. So and I better get rid of the thing we just did. Otherwise, it's going to be kind of annoying. This is no game. All right. So if I hang out here and I scroll my mouse wheel, right, I get a mouse wheel event. So there I'm scrolling up, and here I'm scrolling down. And so, and there's up. And let me close this out so we don't lose that. So when you do a mouse wheel motion, if you trap that, right, you get the absolute coordinates. If you're holding down a button, it will tell you that. Here's the number of clicks that it made, and I've got it set up to single click. But wheel rotation, right, -1 when I was scrolling up, +1 when I was scrolling down, so you can tell which way the person is scrolling it. Scroll amount, so this is from your Windows setting, and various other things. So you can go into the documentation and look up what a mouse wheel listener is, right, and see what kind of mouse wheel events, what the properties are on that, what the methods are you can call, and so on and so forth. So you have the option when you're designing these interfaces to, you know, capture and respond to pretty much any kind of event that you like, and of course to change all sorts of aspects of these objects, right? So I can change the size, the location, the appearance. I can make these visible or invisible. I can you know, take this button and mark it as not enabled. And now when I run this, right, the button is still there, but it's not clickable. So if you've got an option that, you know, at this point of your game you don't want the person to be able to change, you can gray it out by making it not enabled. And from your code, right, I could just say, you know, is enabled, and pass it an argument of true or false, right? So linkages between, you know, these properties we set here, the things that we can do in code, right? So set enabled false, and the corresponding appearance when we actually generate the object. So all three of those are linked together, and we're just trying to build kind of the mental map between those. We should do the stick game. I'm kind of sad because I don't think that's going to work, although I considered giving you the option of building an Easter egg stick game in PA4 for bonus points. So I may do that because that would be fun. All right, so wow, time is flying. All right, let's just play with a few more of these things. So so checkboxes are what you would expect. Radio buttons. So here's a radio button. Here's another radio button. So let's run this. So checkbox, you know, you can check or uncheck, and you can pick up a an is selected method on the checkbox to see if it's checked or unchecked. Radio buttons are, you know, these little circles, but right now, you know, I can fill in both of these circles or just one of them or none of them. That's not really a radio button. Okay, so radio buttons are so named from, like, I don't know if anybody has or remembers old style radios in cars with mechanical buttons on the front. And, you know, typically you had 5 buttons that you could use to select one of 5 different stations. And when you push in one button, the other button that was already pressed in would get pushed out. It was a mechanical selection mechanism to choose a station. And if you dialed in a station that you liked, you could pull the button out, push it in, and it would lock it to that station. And so radio buttons, typically only one of them can be pressed at a time. So if you want the same effect here, restart Eclipse after it crashes. Yeah, that's why they're called radio buttons, and that's why they talk about locking in your dial. I think it's locking in that push button. So let's come on, you can do it. Let's right click on this radio button and let's say set button group, and we'll just say a new standard button group. And then if I right click on this one, I can say set button group, and I'll use that same button group I just created. And now if I run this, right, we have one button. If I select the other one, that first one gets unselected. And so I could put a bunch of buttons in here, and it lets you pick, one out of a number of options, as opposed to checkboxes where you might, pick more than one. All right, so I want to show you, but we're out of time right now. I want to show you how to pick up the check state of this, because it's a little different, but it's similar to something we'll do a lot of. I want to talk about inner classes tomorrow and look at what all of this stuff means. All of these this thing. If you really dig into the syntax of this, it looks very strange. We're actually calling a method, and the argument we're passing in parentheses is this, which is the declaration of an entire class. Right? So we can actually define a class in line and pass that as an argument to a method. So I want to see what that's about. And then I want to talk about Java doc, and then we're going to go on to PA4. So we'll try to get through this tomorrow. Thursday will be an open lab, and then Friday PA4. All right, cool. Have a good afternoon. I will see you tomorrow.